This is page 3 of review worksheet 2. So continuing on, the next objective that we're looking at is we want to be able to determine where a function is increasing, decreasing, and constant. So you'll be given a graph, and we want to find those intervals. So increasing, remember, is going up and to the right. And so if we notice, we're decreasing up until this point right here, which on my graph it's hard to tell. But on your graph, that point is -4. And so from when x is -4 all the way until right here, which is when x is 0, that's when my function is actually increasing. So when we're talking about these intervals, we're always talking about the x values. We're talking about what x value does my interval start and what x value does my interval end. So in this case, right, where that whole part of our graph, that's when it was actually increasing. And so this is no other part of this graph is increasing. So that's the only interval we have for that one. Now decreasing, same thing. We want to look at the x values at starts and ends. So from here, I'm actually decreasing. And that point on my graph, again, it's hard to tell. But that's actually the point, that's when x is -7. So when x is -7, that's right there, all the way until here, when x is -4, that's when the part of my graph is decreasing. And so now I just have to check if any other parts are. So this whole part was decreasing, and then boom, right here, I can see that I actually have another decreasing portion. So again, if you want, you can write union, or if you write comma, whatever works. I'm going to write union. So from when x is 0 all the way until, in this case, right here, that's when I start to level off. So that point right there, that's when x is 3. So from when x is 0 until when x is 3, that's when I have another decreasing part of my graph. So that's this whole part right here. And then constant, that's just where I'm not decreasing or increasing. So I'm not changing height. So in this case, we're talking about from when x is 3 until when, right here, when x is 8. That's when I have a constant part of my function. So confidence hopefully is getting better on those two. So now we're done with number 9. Moving on to number 10, we want to be able to use the graphing utility to calculate the local max and local min points on a graph. So again, you need your calculator for this one. So if you bring up your calculator and you go home and add a new document, now all you have to go is go down to number 2, add graphs. And oops. So again, go home, go to number 1, new document. I don't care about saving, and add graph. So now I'm just going to type in my function in there. So in this case, we're at 0.25 x and then cubed minus a 3.8 x squared plus 4x minus 6. So once I get that in there, now I'm just going to hit enter. And I can see part of my graph, so I'm going to kind of drag. And to get a better feel for what's going on, I'm actually going to go to zoom fit to see, okay, there we go. Because before, right, it only looked like we had a maximum. But if we look at this, I'm going from increasing to decreasing, and then decreasing to increasing. So that's where my max and min are going to be. And notice, from here, now I just need, there's 2 different ways we can do this. I like to do, you can do trace, but the other way you can do is you can go to menu and then analyze graph. And in this case, I'm going to do minimum first. So over here, I go from decreasing to increasing. So that's where I'm going to have a minimum. So all you do is you hit to the right or to the left of the minimum, and then you hit enter to the right, and notice the minimum point pops up. So looking at that, right, that just shows Oh, shoot. And I actually typed in my function wrong. So real quick, I'm going to fix that. So again, if we go up there, this was a negative 0.25. So that was my bad. So that was actually a negative 0.25x cubed minus 3.8x squared plus 4x minus 6. So if I graph that function, it's going to look similar. So again, I'm going to go to menu and then I'm going to zoom fit. And it looks similar, right? We still have our minimum and we still have a maximum. So this is getting confusing. So I'm going to move that. And I want to find my minimum. So again, remember, we go to menu, analyze graph, number 2 minimum, hit to the left, hit to the right, and my minimum point pops up. So when we're talking about minimum as an ordered pair, then this point, ordered pair, we're just going to write it as it seems on the graph. So my minimum is going to be at negative 10.6 and then comma negative 178. So that's where my minimum is going to be at. And then if we go back to our calculator, now I want to find my maximum. So from here, now I'm just going to click and drag my graph back over here so I can see my maximum better. So again, I'm going to go to menu, I'm going to go to analyze graph, and instead this time I'm going to go to maximum. So same thing, hit to the left, hit to the right, and my minimum point pops up, or my maximum point pops up, excuse me. So if I go back to my graph, that was at the point 0.501, comma negative 4.98. So now, as an ordered pair, I had a minimum at this point, and as a maximum, an ordered pair, that was at that point. So that's all we had to do with this part. So we just had to find the minimum and the maximum. So the next thing we learned about doing in this fun chapter was, the next objective was to be able to determine symmetry graphically and classify a function as even or odd. So from here, if I'm looking at number 11, we want to determine the symmetry of this graph. So I want to say, okay, remember when we were talking about this, right? There was a couple times. It was y-axis, origin, or neither. So this section, those are the 3 options that we have. And remember, and if you want to remember those, like with what goes with what, remember it was yes, remember? So origin, it was odd. Y-axis, it was even. So in this case, right, we want to look at this first graph. So the first thing I'm going to check is a y-axis. So y-axis is when we flip it over our y-axis and if we land on our function. So in this case, notice if I were to actually flip this over, it would fall on my function. It would line up. So in this case, y-axis, that just means we have an even graph. And it's along the y-axis. So pretty simple. Then the next thing, now we're going to look at number 12. So what type of symmetry does this have? Well, if we were to flip this over our y-axis, notice it wouldn't fall on itself because this would actually look something like this. And this would look something like this. And that doesn't match up. So in this case, that's why this is not y-axis symmetry. But now we want to check our origin. So it's not y-axis, but let's check origin. So origin, remember, is if we were to actually spin it around our origin 180 degrees, or flip it upside down, if you will. So if we were to flip this down, another way you can think about this is if I were to flip it over my x-axis and then flip it over my y. So this part right here, if I were to flip that over my x, that would be here. And if I flip that over my y, that would be here. And notice it falls, that was a really bad drawing, but it falls along this. So that tells me that this part of my graph, or number 12, has origin symmetry. Or it's symmetric around the origin, about the origin. So from oh yes, remember, if something was symmetric about the origin, that meant it was odd. So this graph is actually an odd function. So So that's even odd. In this case, neither these were not neither. So if it wasn't along the y-axis, or if it wasn't about the origin, then it would be neither. So just like we could do it graphically, we can also do it algebraically. And how we do that, so in this case, if we're looking at 13, 14, and 15, we want to do it algebraically. So to do that, the first thing we're going to do is plug in negative x into our function. So in this case, we're going to go plug it in. This case, right? So negative x is going to be cubed minus 1. I have know where x is, so I'm going to plug in negative x, 4x. And then simplifying farther, negative x cubed, well, any negative number that's cubed, you're going to have a negative outcome. So in this case, this is still going to be negative x cubed minus 1. So now I have to ask the question, okay, is this function the same as my original? So if you notice, this is positive x cubed minus 1. This one's negative x cubed minus 1. So it's not, in this case, it's not the same. So that means it's not even. So I have to do a little more work now. So remember when we were up here, and we were talking about, oh yes. So graphically, if it's not even, then it's going to be either odd or neither. So if it was odd, remember it was the opposite function was the same as our original function. So, or is the same as when we plugged in negative x. So I want to see what the negative of my function is. So if I plug it, I'm going to make the negative of my original function. So if I'm going to make that negative, I have to make the whole top negative. And then distributing the negative, this is going to be negative x cubed plus 1. So now this is where I check. I'm going to check if this is the same as this. In this case, so we have a negative x cubed and negative x cubed. That's fantastic. But I have a plus 1 and a minus 1. So that tells me that these are, since this is not the same as this, that it's not odd. So in this case, this is neither. So this one is neither. So notice when we actually have something that's not even, we have to do more work. But we'll check on this one. So again, when we're finding if a function is even, odd, or neither, the first thing we do is plug in negative x. So if I plug in negative x into this, so f of a negative x is going to be 2 times negative x squared minus negative x to the 4th. So now I just need to simplify. So in this case, we're going to get a negative x squared. Well, that's just going to be any negative number squared is going to be positive. So in this case, this is going to be positive 2x squared. And then here, when we have a negative x to the 4th, anything with an even power, that whatever is inside is going to be a positive number. So in this case, I'm going to be left with a negative x 4th to the 4th. And now I check. Okay, is this function the same as this one? So we have a 2x squared minus x to the 4th and a 2x squared minus x to the 4th. So since they are the same, or since those are the same, this one, we don't have to do any more work because that means that they are even. So number 15, we want to find if it's even or odd. So I plug in negative x. And we're going to get negative x to the 6th minus a negative x. So that is going to, remember, anything inside raised to an even power is going to be positive. So this is going to be x to the 6th. And then here we have a minus negative x. That's going to actually switch to a positive x. And now I say, okay, well, we want to say, is this the same as my original? Since they're not the same, we know in this case that they're not, this is not going to be even. So I have to do the extra step. I want to find the opposite of my function. So I want to find negative f of x. So in this case, right, we have to make everything there negative. x to the 6 minus x. So this is my original function. So distributing the negative, we're going to get negative x to the 6 plus x. And now I need to check, is this the same as this? And since we have a negative x to the 6 and a positive x to the 6, in this case, this one is also neither because they don't match. So that one is also neither. So that's the end of page 3. So stay tuned for page 4.